Okay, I couldn't squeeze this on the other video, so I'm going to put it here. This is just a couple of applications that involve the quotient or product rule. For this one, it says find the slope and equation of the tangent line to the graph at the given point. So here is the function, and so what you're asked to do is find the slope and the equation of the tangent line to this function at the point 1, -3. Now I left it as an exercise for you to do. Apply the product to this function, the product rule to this function, and show that the derivative of that function is the polynomial 4x cubed plus 6x squared minus 6x minus 5. And then after you do that, then we can move on to find the slope. So if you need to, pause the video and do that, and then come back to and restart the video. Okay, so now if we know this is the derivative, then remember this function represents the slope of the tangent line to this graph at any point. So if we want the slope of the tangent line at the point 1, -3, we simply plug in x equal 1. So let's do that. Let's plug x equal 1 into this derivative. So if I plug 1 in, I'm going to get 4 plus 6 minus 6 minus 5. Well, that's just going to be, the 6's cancel, so I'm just going to get 4 minus 5, which is -1. So the slope of the tangent line at the point 1, -3 is actually -1. Now notice I gave you both the x and the y value here. I could have just given you the x value and left it up to you to get the y value by plugging x equal 1 back into this function. Okay, now, but anyway, we know the point, we know the x and y value of the point in question, 1, -3, and now we know the slope of the line that goes through the point. So if we know the slope and the point, we can use the slope point formula or point slope formula to get the equation. So here's the point slope formula for the equation of the line, and I'm going to use y1 is -3, so y minus 3 would be y plus 3, and then the slope, remember, is -1, and then here I have x minus x1, and x1 is 1, so I have x minus 1. And then just distribute -1 through here, and I get minus x plus 1 over here, and then subtract 3 from both sides, and I get y equals minus x minus 2. And if you wanted to, you could graph this function here, and then graph this tangent line on the same graph, and you would see that this line actually does appear to be tangent to this function at the point 1, -3. The next example says find any points where the graph has a horizontal tangent line. Okay, well here is a quotient, x squared over x squared plus 1. And again, I'm going to leave it as an exercise for you. If you need to, pause the video and apply the quotient rule to this function and see if you can get this derivative, 2x over x squared plus 1 quantity squared. Now, and when you're ready to come back, just restart the video. Now, in order to find where we have a horizontal tangent line, we simply set the derivative equal to 0. Okay, so to set this derivative equal to 0, basically this derivative is a fraction, and the only way that a fraction can be 0 is if the numerator is 0. So really all we're doing is solving the equation 2x equals 0. And if you solve that equation, you'll get x equals 0. Okay? Now, we need the y value, so I want to get the y value as well, because it says find any point or points. So to get the y value, don't plug it into the derivative, even though it would give you the same value, but that's not the point. You want to plug this x value 0 back into the original function. So if I plug it in here, I get 0 squared over 1, so I get 0 over 1, which is 0. So the y value is 0 as well. So a horizontal tangent line occurs on the graph given at the point 0, 0. And again, I challenge you to graph this and look at the point 0, 0 and to see if you can see that you get a horizontal tangent line there. Now, the only way to get a vertical tangent line is if the derivative is undefined at a value. Well, the only way this derivative would be undefined is if the denominator could be 0. But the problem is, since we have x squared plus 1, there's no real number that you could square that would give you negative 1, because that's what x squared would have to be for the denominator to be 0, is x squared would have to be negative 1. And since you can't square any real number and get negative 1, then there's no places where the derivative is undefined. So there are no vertical tangent lines since the denominator cannot be 0. Now, doing the same thing for this one, we'll let y equals x times the square root of 3 minus x. Now, I'm going to go ahead and we're going to cheat on this one a little bit. I'm going to go ahead and give you the derivative of this one, okay? Because you don't really have the tools yet. You actually need the chain rule before you can actually complete the derivative of this one. I mean, you would use the product rule, but the problem is you have 3 minus x to the 1/2 power, and we don't have the tools yet to deal with that. So let's just go ahead and trust me that this is the derivative of this function. So now let's focus on the derivative. Like I said before, the only way that you can get a horizontal tangent line is if the derivative is 0. And since the derivative is a quotient, the only way it can be 0 is if the numerator is 0. And of course that also means if the numerator is 0 and the denominator is not 0. So the only way this could be 0 would be when x is 2. Okay, so now I know that we're going to get a horizontal tangent line at x equal 2. And if I want the y value, just go back in here, plug 2 in here, and plug 2 in here, and you'll get 2 times square root of 1, which is 2. So the point is 2, 2. So at the point 2, 2, the derivative would actually equal 0 when x is 2, and so the associated point would be 2, 2. So we get a horizontal tangent line at the point 2, 2. Now, as far as a vertical tangent line, you get a vertical tangent line when the denominator is 0. Well, the only way the denominator could be 0 is if 2 times square root of 3 minus x could be 0. And the only way that could be 0 is if the value that's in the radical could be 0, which is 3 minus x. And if you set that equal to 0 and solve it, you get x equal 3. So at x equal 3, we're going to get a vertical tangent line, and the y value at x equal 3, if you plug 3 in here, you get 3 times square root of 0, which is 3 times 0, so that would give you the point 3, 0. So you get a vertical tangent line at the point 3, 0. Now, if I remember this graph, basically what happens here, you might have to zoom in on it to get a good picture of it, but what happens to this graph is it kind of comes down here and then takes off in this direction. Okay, so right here at the point 3, 0, you get a vertical tangent line. So that's the point 3, 0, and and I may have this backwards, but I do know that you kind of get a vertical tangent line here at 3, 0, and I must have it backwards because I believe it might go more like this. Okay, so here at 3, 0, you get a vertical tangent line, and then here at the point 2, 2, you're going to get a horizontal tangent line. Again, I may have the graph wrong, but the point is that you'll see that you get a vertical tangent line. If you graph this function, you'll see you get a vertical tangent line at, well, let me just go ahead and check the graph and show it to you the correct way. Okay, they say third time's the charm, right? Okay, so the graph actually does this. It kind of comes up and then turns around, and so right here is the point 2,2, and that's where you get the horizontal tangent line. Then it comes into and hits the x-axis at the point 3,0, but when it hits the x-axis at 3,0, it actually goes vertical right there. So you get a vertical tangent line right there. So anyway, that's hopefully that'll help you with some of the examples using the product and quotient rule to solve them.